Okay, pre-calc students, in this short video, we're going to look at the idea of orders of magnitude. Again, we're looking at logarithms and then how logarithms might actually apply to some real-life concepts. So, first application is with the idea of orders of magnitude, a way of describing really, really big numbers in as manageable, smaller numbers instead. So the order of magnitude would be the common logarithm of a positive quantity. So common logarithm, understand that's a base of 10, and that would be the common base 10, as I was saying. Sorry about the interruption there. So a common logarithm would be the power to which I would be raising a base of 10 for a particular number. So if I've got 10 to the 8th power, let's say, that describes a particular number, the order of magnitude for that number would be the 8, because that's the logarithm or the exponent to which you would raise a base of 10. So orders of magnitude can be used to compare any like quantities, such as the ones you see here. So a kilometer is 3 orders of magnitude longer than a meter. Reason being, if you think about a kilometer, well, a kilometer would be 1,000 meters, which if you write that as a power of 10, that would be the same as 10 to the third. Whereas a meter would be just, well, 1 meter. And if you wrote that in scientific notation, that would be 10 to the 0 power. So when I compare the orders of magnitude, a kilometer is 3 orders of magnitude longer than a meter. Similarly, a dollar is 2 orders of magnitude greater than a penny. So a dollar, we've got, $1, and then a penny would be a hundredth of a dollar. So if, again, writing these as powers, I'd have 10 to the 0 to represent 1. I'd have 10 to the negative second to represent the hundredth of a dollar. That is a penny. Well, that's a difference of 2 in their orders of magnitude. And finally, a bigger one, if I've got something like New York City has 8 million people, well, 8 million people written in scientific notation, that would be, 8, and then we'll write out a million. So you see it, real sloppy like. Well, 8 million versus Earmuff Junction, apparently a tiny little town that's got a population of 8. If you write those both in scientific notation, you're going to have 8 times 10 to the 6th versus 8 times 10 to the 0. And so again, we're comparing the common logarithm, which happens to be the exponent. So my order of magnitude would be 6 orders of magnitude bigger when it comes to New York City versus Earmuff Junction in regards to their population. So just a quick little look at orders of magnitude and their connection to logarithms.